Artificial intelligence. You have probably heard of it before or even already make use of it. After all, it has made its way into many different things, such as smartphones, chatbots, self-driving cars and more. But what is AI really? In this McCoy TV, we look behind the scenes to figure out what makes AI tick. My name is Jelle, part of the AI initiative here at McCoy. When you think of artificial intelligence, you might picture human-like intelligence. But in reality, AI is built on principles that are surprisingly simple to grasp. In this episode, we'll focus on one of these key principles, neural networks. We'll quickly get you up to speed, and in the meantime, please be patient. It will all make sense by the end. Artificial neural networks form the heart of modern AI. It is a model inspired by the human brain. Your brain is made up of billions of neurons that communicate with each other to help you think, feel, and act. Neural networks and AI are kind of like a simplified mathematical version of this idea. Such a neural network is divided up in three kinds of layers: the input, the hidden layers, and the output. These are connections between the neurons on each layer, which are referred to as activations. The goal of a neural network is to predict the output based on an input. These inputs and outputs can be almost anything you desire: words, numbers, images, or even sounds, you name it. An input will travel through the various hidden layers, which are responsible for processing the data, and eventually reach the output layer, which shows the value the network has predicted. The activations, connections between each layer, have a weight value associated with them. This represents how strongly a neuron is correlated to the neuron in the next layer. These weights essentially define the logic of the network. To get a neural network to predict accurately, we go through a process called training. During training, we supply an example dataset of the inputs paired with the expected output. An algorithm will take these inputs, run them through the network, and compare the expected output with the actual output. Subsequently, an algorithm will adjust the various connections in the network from the back to the front so that the next input the network receives will be closer to the expected output. This technique is called backpropagation. Let's look at an example to get a more practical sense of how a neural network behaves. A classic example is a neural network that can recognize handwritten numbers. The input in this case is a black and white image of a handwritten number. Each neuron in the input layer represents the brightness of 1 pixel in this image, a value between 0 and 1. These inputs then travel through the hidden layers. The weights of the activations determine which neurons in the next layer get activated. After many layers, the output layer is reached. Each neuron in this layer represents a possible output, in this case 0 to 9. The neuron with the highest value represents the most likely output according to the network. During training, we compare the result of the network with the expected result. If there's a mismatch, the various activations between the neurons in the layers will automatically be adjusted by an algorithm to make the network more reliable in the future. I hope this gives you an idea of how neural networks work. By now, you can maybe see how a neural network could potentially be useful for certain applications. However, you might now also like to know how this relates to the AI tools you might be familiar with. Let's look at just one of them, a popular tool like ChatGPT. To see how the two are linked, let's break it down. ChatGPT is a tool that provides instant assistance across a wide range of topics, enabling users to solve problems, learn, and create effortlessly, right? But let's look at it through a more analytical lens. ChatGPT takes your text, your question as input, then it processes it and predicts an output, the answer to your question. This sounds eerily familiar, doesn't it? Indeed, ChatGPT and other tools like Microsoft Copilot and Google Gemini are referred to as LLMs, large language models. The large language models are, in essence, neural networks, but on a much larger scale, so that they can process something as complex as language. Other AI tools you may use, even though they might not be LLMs, most likely do use a neural network as well in some capacity. taking an input and using that to predict an output. So, in short, AI isn't magic, but consists of various principles, such as neural networks. These neural networks can predict an output based on an input you give them. We train neural networks using a dataset of inputs and expected outputs to make them accurate. AI tools such as ChatGPT work by building on top of principles such as neural networks. There are many more exciting developments to come, so if you enjoyed this breakdown, subscribe to our YouTube channel and follow our blog to stay up to date on AI and what it means for the future of SAP. Thanks for watching, and I hope to see you again soon. Take care.